Today, our physical world is learning to navigate itself. Autonomous cars track every surrounding object in milliseconds, and drones calculate flight paths to reach your doorstep. But who builds the actual systems that allow these machines to interact with reality? A piece of software on a screen can't physically turn a wheel, and a frame made of metal and plastic can't observe the road. On their own, the digital and physical worlds are disconnected. Electronics and communication engineering is the field that builds the bridge between them. It's the discipline of giving a machine a nervous system through electronics and a way to share information through communication networks. These engineers are the invisible architects of our modern environment, designing the pathways that allow a digital command to become a physical action. Everything starts with a simple circuit. Connecting a battery to an LED creates a path for energy to flow, producing light. We use that same flow to carry information. A TV remote sends pulsing infrared light, which a receiver translates into a digital command. To handle thousands of these signals at once, we need a way to organize them. This is why we use microprocessors. By shrinking millions of these individual electronic paths onto a single silicon chip, we can create a system capable of making complex decisions in an instant. Once you understand how to control these tiny electrical actions, you have the building blocks for nearly every piece of technology we use today. When you layer these components together, you get an embedded system. In a smartwatch, an optical sensor reads the light reflecting off your skin to track your pulse, while a tiny processor calculates your heart rate and a transmitter sends that data to your phone. This logic allows machines to react to their surroundings without human help. It's how grocery store doors detect your motion to slide open, or how traffic lights monitor the number of cars waiting and adjust their timing to clear a jam. By combining sensors with processors, engineers turn static objects into active, intelligent systems that can solve problems on the fly. But the true power of these devices comes when they connect. Engineers build the wireless networks, like Wi-Fi, Bluetooth, and 5G, that allow billions of separate machines to share data instantly across the planet. This requires signal processing. This diagram shows how a microphone captures the continuous, wavy sound of a human voice and instantly breaks it down into a digital stream of ones and zeros that a computer can understand and act upon. This network extends into space. Satellite arrays allow us to monitor crop health across millions of acres of farmland, or track the location of electric vehicles across an entire continent. This effectively creates a planetary nervous system, where a device in your hand can communicate with a machine orbiting thousands of miles above the Earth. The field is currently moving toward even tighter integration. Engineers are developing brain-computer interfaces that allow people to control prosthetic limbs with their thoughts, and 6G networks that could make lag time a thing of the past. These advancements are being used to tackle massive hurdles, from deep space communication to wearable monitors that can predict a health crisis before it happens. Because these systems are essential to almost every industry, the demand for ECE engineers is constant. You'll find them in semiconductor plants, inside robotics labs, at space agencies, and artificial intelligence research centers. A career in ECE puts you on the teams that decide how we will move, communicate, and care for one another in the coming decades. Every device we rely on today began as a simple observation or an idea in a student's head. The next breakthrough in how we connect with our world is waiting to be designed by someone currently sitting in a classroom. From smartphones to satellites, from robots to artificial intelligence, electronics and communication engineering is shaping the future. Dream, innovate, create. Become an electronics and communication engineer.